So in this video, we're going to be talking about yet another rule for differentiation, and this one is called the quotient rule. And the quotient rule is the rule we use to take the derivative of some function when that function basically has some division in it, when you have two functions being divided by each other, or you have a quotient. And so this formula is what tells us how to take the derivative of a function when we have that division going on. And so what this formula is saying is that we have some function on top of the division symbol and some function on the bottom of the division symbol. And in this formula, they used f of x as the function that's on top and g of x as the function that's on bottom. And so when we take the derivative of some function, so if we have some function y equals f of x, divided by g of x, and we want to take the derivative of this, we want to find y prime, this is what we're going to do. We're going to take whatever function's on bottom and multiply it by the derivative of whatever function was on top. Then we're going to subtract whatever function was on top multiplied by the derivative of whatever function was on bottom, and then that's all going to be divided by whatever function was on bottom squared. And so that looks like a big mess, but once you get into a few practice problems, you'll see how this rule gets applied. So here we have a function y, and y is equal to 3x plus 5 divided by 5x minus 3. And we want to find y prime, or the derivative of this function. And so how you recognize that you're going to need to use quotient rule is that you have two functions being divided by each other. So that's different from product rule, because with product rule we had two functions being multiplied by each other. But now with quotient rule we have two functions being divided by each other. So that's the difference, and that's how you're going to know which rule to use. So quotient rule says that we have some function on top, so this 3x plus 5 is going to be our top function, this one in red. And then our 5x minus 3 is going to be our bottom function, this function in green right here. And so we want to take the derivative of this whole thing. And so we can apply this formula over here to do that. So it's really important that you recognize that we have a bottom function and a top function. The top is this red one and the bottom is this green one, because I will be referring to them as the top and bottom. So if we look at this formula over here, g of x is our bottom function, and this says to first just write g of x like normal. So our bottom function is 5x minus 3. So we're going to write 5x minus 3 like normal. And don't forget to use parentheses, always a good habit. So there's our g of x, our bottom function. We just wrote it like normal. And then this formula says multiply that by the derivative of the top function. And so our top function is this 3x plus 5. So what's the derivative of 3x plus 5? Well, the derivative of 5 is just 0 because it's a constant, and the derivative of 3x is just going to be 3. So the derivative of our top function is 3. So we multiply. And then this formula says we need to subtract, and we need to subtract the top function written normally. So our top function was 3x plus 5. So we're going to do 3x plus 5. And now we need to multiply by the derivative of our bottom function. So our bottom function is 5x minus 3, and so the derivative of that is just going to be 5. And then this formula says all of this needs to be divided by the bottom function squared. And our bottom function was 5x minus 3, and we need to square it. So we're going to do 5x minus 3, and then square it. And this right here is a very, very common mistake, so put a star so that you pay a lot of attention to it. When this formula says square the bottom, it means square the bottom. It means put parentheses around everything that's on the bottom and square it. I see a lot of students sometimes, if the bottom was 5x minus 3, instead of putting parentheses and squaring the whole thing, they'll just put a little squared there, and hopefully you know from algebra, but that is not the same as putting the whole thing in parentheses and squaring it. So pay really close attention. Do not do that. Pay really close attention to this formula, that the whole thing on the bottom gets squared. And so this right here, this y prime, is our derivative. This 5x minus 3 times 3 minus 3x plus 5 times 5 all over 5x minus 3 squared. So that whole thing is our derivative, and we calculated it by just following this formula piece by piece. And so make sure you're comfortable with that the top function and the bottom, because again, I will refer to it a lot like that. And make sure that you're careful with this formula, because another common mistake is that, like right here for this first piece of this formula says g of x times f prime of x. So notice there's no prime symbol on the g right here. So that means that your bottom function, your g of x, is normal. It stays the same, right? Notice right here, I have 5x minus 3. This is the bottom function just rewritten. I didn't do anything to it. And then I took the derivative of the top function. So a lot of students will sometimes accidentally take the derivative when they're not supposed to, because you're supposed to write just the bottom function normal, and students will kind of just take the derivative of everything and throw it in there. So make sure you pay close attention to that, is not all of these pieces have prime symbols on them. And so if not all of these pieces have prime symbols on them, they're not all corresponding to a derivative, right? This g of x right here doesn't have a prime symbol, this f of x right here doesn't have a prime symbol, and then the g of x on bottom doesn't have a prime symbol either. So you're really only calculating a derivative 2 times for this f prime of x and that g prime of x. For the other pieces, you're just rewriting a function that was already there, either the top or bottom. So make sure you pay really close attention to that. So here we have another function y, and that is equal to x to the 5th minus 3x to the 4th, all divided by x squared plus 7x. And we want to find the derivative of this function. So we want to find y prime. So again, we're going to be using quotient rule because we have two functions being divided by each other. We have this top piece that I've written in blue, and then this bottom piece that I've written in purple. So again, we just want to go through the motions and apply this same formula. So this formula says that we're going to take the bottom function and just rewrite the bottom function like normal first. So the bottom function is my purple one, right? The x squared plus 7. So I'm going to take the x squared plus 7x. That is my bottom function. So I just rewrote my bottom function. I didn't do any derivatives, I just rewrote it. So x squared plus 7x. And now we need to multiply this by the derivative of the top. So here's where I'm actually taking a derivative. So the top is x to the 5th minus 3x to the 4th, and we need to take the derivative of that. So the derivative of x to the 5th is going to be 5x to the 4th, and then the derivative of 3x to the 4th is going to be 12x to the 3rd. So that is the derivative of the top. And now we need to subtract, and this formula says we're subtract the top one normal. So my top one, my blue one, is x to the 5th minus 3x to the 4th. So I just rewrote that like normal, didn't do a derivative. And now I need to multiply this by the derivative of the bottom. And so my bottom is this x squared plus 7x. So the derivative of that, derivative of x squared, is going to be 2x. And then the derivative of 7x is going to be 7. So that right there is the derivative of my bottom. And now the formula says that this all gets divided by the bottom squared. So the bottom is x squared plus 7x, and I need to square that whole thing. So again, notice that I took the bottom, I put the bottom in parentheses and squared the whole thing. Please don't just put a squared on each term individually. Use parentheses and square the whole thing. A very common mistake. Another thing that a lot of students ask is, looking at this derivative, this y prime, it's quite long and messy, so they ask, do I need to simplify it? Because we could go through and distribute all this multiplication and combine like terms and whatnot. And so my answer is no, and especially for the AP test, they do not require you, if you're just finding derivatives, to simplify your answers. So unless you are specifically asked on a question to simplify your answer, unless they specifically ask you for that, then I would just leave it, because you do run the risk when you simplify of accidentally multiplying something wrong or missing a term somewhere. So if your question just asks you to find the derivative, then this is perfectly acceptable. This whole thing is our y prime. This is the last example that we're going to look at, and so we're going to again use quotient rule here because we have two functions, one on top and one on bottom, being divided by each other. And so we want to find y prime. And to find y prime, we first take the bottom function and we just rewrite it. So our bottom function is this x to the negative 2 plus x to the negative 5. And then that is going to get multiplied by the derivative of the top function. And so this is our top function in blue here. So the derivative of x to the negative 4 is going to be negative 4x to the negative 5. And then the derivative of x to the negative 9 is going to be negative 9x to the negative 10. But be careful, there was already a minus out front here, and when we bring the negative 9 down, the negative in the 9 is going to multiply by this negative that was already out front, so that's going to turn into a positive. So we'll have a positive 9x to the negative 10. And now we need to subtract the top function just rewritten. So we'll have x to the negative 4 minus x to the negative 9. And now this is going to get multiplied by the derivative of the bottom piece. So the derivative of the bottom piece, derivative of x to the negative 2 is going to be negative 2x to the negative 3. And then the derivative of x to the negative 5 is going to be negative 5x to the negative 6. So that right there is the entire numerator of our derivative. And don't forget, this all has to be divided by the bottom squared. And so our bottom function is x to the negative 2 plus x to the negative 5, and then we need to square that entire thing. So this right here is our y prime, our derivative. And notice that I use parentheses around all of these. That's a really good habit to be in, especially because one common mistake is that this negative right here in the middle, this negative should be multiplied by all of this because that's all in parentheses. And so a really common mistake is to forget to distribute this negative to this entire thing over here. So that's why using parentheses is super helpful, because it's a bit easier to see that that negative right there needs to be distributed to everything if you write everything in parentheses. So that's just a good habit to be in. Hopefully this video was helpful. Again, if you have any kinds of problems that you want to see or different examples or concept, make sure you leave those in the comments, and don't forget to subscribe.